Hello all, this video is on using ArduSim emulator, which is a freeware simulator tool to easily experiment and debug with Arduino programs without a physical hardware. It is written by Professor Simmons of Queen's University, Canada, and it is available for download as a freeware. The download link is given in the description below. You can download the latest version. The download is available as a zip file. Unzip the file and you can see a folder inside with the .exe file is there. No installation is required. You can just copy and paste the folder anywhere in your PC. Now open the exe file. This is the welcome window of UNOARDUSIM. Left side is the code pan where a demo code is displayed. At the bottom of the code pan is the explicit reference to main function. This is the C code behind the while setup and the while loop of Arduino code that is shown for execution purpose. Below that is the variable pan. In this variable pan it shows the current values for active in scope variables. To the right is the lab bench pan. It shows a virtual surrounded by set of IO devices. You can select and customize the IO devices shown surrounding this virtual On the top is the menu bar for loading file and the execute command and configure. To the bottom of that is the toolbar buttons including debug tools for debugging the code using step commands, and then run to run the program, stop for stopping the execution, and then the reset button. At the bottom you can see the status display. First let us see the configure button. Click on configure. There are two options, IO devices and preferences. Click on preferences first. Here you can opt for auto insert for closing braces and then semicolons, and then you can select the board. By default V2 version 2 is selected. If you want you can select Mega also. Mega is also supported. If you click on Mega and then upload, on the bench view you can see a Mega virtual board. Now go back to the configure preferences and select version 3. By default it is version 2. Now select version 3. Version 3 has got SDA SCL pins near the pin 13 and it is the advanced board. Let us load this, and again from configure click on IO devices. Here you can see a set of IO devices. That is by default these are all loaded. That is 2 numbers push button. You can see the 2 numbers push button here, and then switched resistor 4 numbers. This slide resistors connected to pin with 1K pull up or pull down, and then piezo speaker 2 numbers. You can see at the bottom 2 numbers piezo speakers, and colored LED 2 numbers. So you can assign any pin to this colored LED to drive the LED. It has got hidden resistor 1K, and then one 4 LED row. This row of 4 LEDs and 2 numbers 7 segment LED. You can give the hex code and assign the pin number to display the 7 segment, and a pin jumper is there 1 number, which is used for with interrupts to connect 2 pins. And there are 2 sliders. That is the analog slider. It produces static analog level 0 to 1, 0 to 3 to test the analog input. And then in the big IO devices you have got a servo motor 1 number, and then a DC motor, and stepper motor is there. If you click on that it will show too many big IO devices. So if you want to include stepper, you have to delete some other IO devices and then include this. And there is also digital pulse function generator and alt serial for software serial, and USB serial and TFT all are there. You can configure as per your requirement. Apart from the IO devices, there are communication peripheral and display windows. These are all detachable windows. The first one is serial window. you can double click on this window to make it bigger. This in this window you can type in any just like typing in keyboard input to UNO, and then inside the virtual UNO you can use the serial.read to read it. Next one is the TFT display. This display can be used to display the output of your code, just like LCD. You can use this display. And the next one is I2C slave. This is slave mode device emulator, and it uses two-wire library. You have to include wire.h in your code, and it is supported by this emulator. Next one is SPI slave, and the next one is alt serial. This is software serial. You have to include software serial.h inside the code to use this software serial. So all these header files are supported by this emulator. Now let us see the sample code loaded. By default this code is loaded. First is integer variable count is declared, and inside the setup it is initialized to 0, and inside loop you increment this counter after a delay of 100 millisecond. At the bottom you can see the C code in the background. So all C code starts with main, and it is implied in this code at the bottom. This is used in the execution purpose. So it C code starts with main, and then setup is called, and then loop is called. Now double click on the code window to open edit view window. You can also use file edit view to open the code edit window. Inside this window you can edit the code. At the right side for your help, all the declarations and include all statements help is provided. And to the right is the compile button. If you press the compile, you can see at the bottom compile parsed successfully. Compilation is called as parsing in this emulator. You have to click on accept to come back to this lab view menu, and now click on run button. You can see the count variable at the bottom increasing every 100 millisecond. To stop the execution, press the stop button to stop the execution. Now for debugging purpose, there are step commands. This is very powerful in this emulator. Step commands are used for debugging. You can use step into, that is F4. You can just press the reset before starting the debugging. Step into or press F4. It steps execution forward by one instruction or into called function. This is used often to step into one by one instruction. There is also step over, that is you can press F5 also. By it is used for step execution for forward by one instruction or by one complete function call. There is also step out to leave from the current function, and then run to. You have to click to highlight a line and then use the run to, and then run till, which is used. You have to run the program until a write occurs to a variable highlight. So it is very powerful in this emulator. Step debugging commands. You can just try this step into to see the command execution one by one. So it is moving one instruction by one instruction. It moves from initially it goes to void setup, and then inside loop, and it increments the variable, and then delay. So one by one it goes. So now click on stop to stop the execution. Now double click on the code pane to open the code edit window. Here you have three options. At the bottom you have three options. One is to tick mark for bold keywords, and the second one is for tab spacing, either 1 or 2 spacing, and then there is a option for auto semicolon at the end of each line. So whatever options you wish, you can select this. And at the right side you've got a list of directives, that is include defined statements, data types, pins related commands, serial function related commands. All are listed at the right hand side. So you can double click it and it'll be taken into the edit window. So the IntelliSense is not a complete IntelliSense, but you can make use of this ready-made commands for code development. There is also find replace button, compile and accept buttons. Now to reduce the clutter of the display lab view, let us go to configure IO devices and let us select only the wanted peripherals. So push button we need one push button, switch resistor we do not need, make it 0, piezo 0, colored LED we'll use one colored LED 1, and 4 LEDs row we do not need, 0 we make it, 7 segment 0, pin jumper 0, analog slider will make use of one slider, servo motor will make it 0, and then DC motor make it 0, SPA slave this also will not be using in this demo, make it 0, I2C 0. So we need USB serial, let it be there, and TFT we do not need. Also alt serial you make it 0, so we are not going to use software serial. Now click on OK. Now you can see all the unwanted IOs peripherals are removed and only wanted peripherals are displayed. So it is need display. Now double click on the code pen to go to the edit window. Change the variable. Let us change the variable, integer variable VAL, and we'll assign it as 0. We'll use auto semicolon facility, and inside void setup we'll make the pin mode 13 as output. So we are going to blink the LED at inbuilt LED pin 13, and inside void setup we'll use the digital write function and make it as high, and we'll use the call the delay function for 500 millisecond, and again we'll use the digital write to make the pin as low. So every 500 millisecond the built-in LED will blink. You can click on the compile button to see the compilation. Compilation is called parsing in emulator. There is also a save button, you can save the code. For now click on the accept button to go back to the lab view. Click on accept to go back to the lab view. Here you click the run button. At the top you see the down arrow, green down arrow. Click on the run button and notice the built-in LED. Now it is blinking according to the code. At pin 13 also you can see the blinking. Now left click on the pin 13, you can see the digital waveform. At any pin, if you want to see the digital waveform, click on left button. To see the analog waveform, click on right button. Now click stop button to stop the execution. Now let us connect an external LED. Already we have included one colored LED box. This colored LED has got 3 options. One is the top box, small box is there. There you have to assign the pin. Let us assign the pin to 13. And the next option is normal. That is when you give high, the LED will glow. That is the default. If you want, you can revert it. And the third option is the color. 4 color option is offered: red, yellow, green and blue. Now let us select B, that is blue. Now click on run. You can see the built-in LED blinking as well as the LED in the LED box, that is a color LED, external LED. Both are blinking according to the code. Now click on stop to stop the execution. Next we'll check the serial window. Before that you can press the reset. It will act as a hardware reset. You can directly press the reset icon on the virtual, it will give a hardware reset. Now double click on the serial window we have added. Now the serial window will get expanded for a bigger view. As it is hardware serial, the pins you cannot change. The RX is 0 and the TX is 1. It is pre-assigned. And baud rate you can change. By default it is 9600. This serial window is detachable, so you can move and place it anywhere on your screen. Now double click on code window to open the edit view. Now inside the void setup, let us add this command serial.begin 9600. That is, we start the serial communication at baud rate of 9600, and inside void loop we'll use the serial.println to print the variable, that is the count. Now click on compile. You get an error. Let us see what is the error. While adding that serial.begin, instead of semicolon we have put a colon, so change that to semicolon and again compile. Now compilation, that is parsing, is you can see success. Now click on accept to go to the lab view. Now click on run button, that is a green down arrow. You can see in the serial window, you can see the variable counting upwards. In the variable window also, that variable is displayed, and inside the serial window also it is displayed. It is just like a serial window of the Arduino IDE. Press the stop button to stop the simulation. Now let us do the modification in code so that you can type something inside this serial window, and Arduino Uno will receive it and act accordingly. Now click on reset and double click on code window to go to the edit window. Now we'll change the variable to VAL and assign it to initial value of 0, and inside void setup we use the pin mode, that is pin mode 13 as output, and serial.begin at 9600, and inside void loop we'll use the serial.read and assign it to the VAL integer variable. So whatever we type from inside the serial window, it will be assigned to the value. And we use the if class and we check the incoming character VAL, and we use the double equal to and a single quote if the value has value is 1, and then we use the digital write to make the LED high, and if the incoming value is 0, we use digital write to make the LED off, and if the incoming value is 2, we blink the LED twice. So if VAL and we use the double equal to operator and a single quote 2, and inside this we use the braces for this if class, we blink the LED twice using digital write function and a delay. We use this code 2 times so that the LED blinks 2 times. Now click on compile. So compilation parsing is success. Now go to the lab view by clicking on accept and click on run. Now you are getting error. So it is stuck up in the serial window, so close this and click the reset button and then press the run button. Now type in 1 inside the serial window and click to send. Now you can see the LED has switched on. Now type in 0 and click on send. The LED has gone off. Now type in 2 and click on send. You can see the LED blinking twice. So 1 is to make the LED on, 0 to off, and 2 to blink twice. So this is the serial operation. Next we'll test the analog input using the slider. Before that, you press on reset and then double click on code to open the edit window. Now we'll modify the code. Inside the void setup, we use pin mode to make pin 5 as output. We'll be connecting one LED at digital pin 5. So we use the pin mode function to make it as our output. And inside void loop, we use integer variable slider, and we assign the analog read of A0 to that variable, and then we use another integer variable t to map that variable we use the map function to map the value of the slider from 0 to 1023. It will convert to 0 to 255, that is 8-bit. And finally we use the digital analog write operation, not digital write, analog write operation, to write on the pin 5 the value of the mapped value, that is a variable t, and then we use the delay. Click on compile. Now the parsing compilation is success. Click on accept to go to the lab view. Now already we have a colored LED. Assign that to pin 5, and the slider is at the right bottom. You assign it to A0. You have to use capital A0. Small letter will give error, so capital A0. Now click on run. Now move the slider using the mouse. You can see the LED, external LED. The brightness of the LED varies according to the slider, so it is the fading effect given by the analog input. Use the slider, and this variable also you can see in the variable pan, slider variable and then the t variable. T variable you can see it is mapped between 0 to 255. Next we'll test the stepper motor. From configure IO devices you can see a stepper motor which is unipolar, which is driven by ULN 2003. Here we are going to test the bipolar, which is pulsed stepper. Select that and then click on OK. This pulse stepper is bipolar and is driven by L293, 298, A4988 or DRV8825 physically. But in this emulator we will be using the virtual pins. It has got 3 controls. So from configure IO devices you need to include 3 push buttons for 3 controls. So these 3 push buttons are assigned to enable, direction and step. Inside the P stepper also you have to assign this pin 4 for enable, direction for pin 5 and step is 6. And inside the 3 push buttons we assign the first one to enable, 4, pin 4, 5 for direction and 6 for step. And we have to write the code for the stepper now. So double click on code window to open the code, edit code, and feed in this code. So inside the void setup we use the pins 8, 9 and 10, 11 for 2 phases of the bipolar. Bipolar has got 2 phases, so we make it as output. And inside void loop we use the analog read A0 and assign it to the sensor reading, and we map it to 1 to 20. So 20 steps make 1 rotation, and we provide the steps sequence 11, 9 and then T according to the analog read, T delay, and then 10, 8, 9, 11, 8, 10. This is the sequence. Now click on compile and then accept to go to the lab view. Now you can click on run and select the enable, that is the 4 enable button. It will automatically run according to the direction. The direction is selected. If you want the other direction, select the pin 5, the other direction, and use the step to rotate it. You can also use the analog slider to change the speed of the stepper. So this is stepper motor testing. So you can use this audio simulator for testing your code effectively. Thank you for watching.